La 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 la. Unfortunately, bright light is impossible. Let's get this started with people. Today, this is the last episode, and we're going to talk about general physics information. Now, general physics information is something all of us should know, at least about science. They teach this in science class, although they don't exactly call it physics. When they do teach it. The thing is, this general physics information is one of the most important information you'll probably need in your entire life. Is what this light refract. Like da 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 da. Like that. That's how Morse code works, technically. And you basically need to know your measurements, the symbols towards all things, the equation symbols and graphs, how to measure stuff, and what happens when the measurement tool is broken, accuracy and errors that are possible, and fields and forces, and that's about it. So this video will probably only take like 5 minutes. Let's start with quantities and units. Now, units are the most fundamental basics that you need to know when you're trying to do physics. Because if you have no units, then you basically can't measure anything, because then you're basically going to have to make up your own units, and someone else will have to make their own units, and then you're gonna have to confuse each other about, because you made your own units and your own measurements, and there's no general unit, so everyone has to like, hey, I'm using mine, and everyone's get confused. So basically, velocity, we use the symbol V for x, and here are basically all of the basic ones you need to know. Velocity is V, acceleration is A, force is F, work is W, and so on. Just pause the video and read all this, or take a screenshot. And this one right here is all of the others, all the meanings of them. Like everything, other information that's linked to these symbols and to what they mean. And these symbols you have to know because they are the most fundamental things you really need to know. And then we also need to know equations. Now, just because some textbooks don't show you equation just because they're trying to be fun, doesn't mean you have to forget the equation. No, you have to remember force equals mass times acceleration, that an opposite reaction, that a reaction has an opposite but equal reaction. An action has an opposite but equal reaction. Yeah, that's better. Like density equals mass divided by volume, like mass equals density times volume, and volume equals mass divided by density. Like, oh, you still need to know that kind of stuff, and it's really useful to actually use those triangle pyramids to remember those equations. I'll give you that. Also, I arguably just memorize them all, just plain flat out. And then we have measurement. Now, you basically know how to use measurements, right? You just need a ruler. Luckily for me, I have a triangle ruler, meaning that this one shows 1 divided by 200 meters. Whatever that means. This one has loads of other measurements. However, this one is not the one we really want. And this one is what we really, really, really want. This is the centimeter. This is the centimeter ruler, and this is the most common universal tool that we've ever used. Oh yeah, and this is most likely, what is this? And, well, don't actually use any of the other measurements as I already showed, because those are not really universal. Use the red one right here. And what happens if your ruler is broken, like, at the end, so that 0... Where the heck did that thing go? Here we go. It's on the next page. 0 seems to be like a little broken, shall we say. Well, that's where errors come in. And you really need to fix those errors. Let's say like 0 is like numbed out on this side. And so you only have 1 millimeter as the starting point. Well, either you can start at 1 millimeter and minus 1 millimeter every time you're literally measuring something. Or you can just go to the next mark, that's the easiest to see, the 10 millimeter, and just subtract 10 millimeters from every measurement you've taken, which is kind of a big of a hassle, so I'd probably just say take good care of your ruler, or get rulers that don't have zeros on the end. Hello? Yes. And significant figures are also something you really need to know next. Because significant figures just means how many decimal points you need to do it to. Like how many, like if you've told for 2 significant figures and you'd like 7 point whatever, like the first digit number and then the 10th digit number. Your one significant number, just put in the first digit number. and 5 significant figures, just putting the first 5 digits, starting from the one side, not the decimal side, so. Fields and forces. We're not going to talk about nuclear force, though, which is kind of a big shame. And this is how it all seems to work out. Gravity, electricity, and magnetism. Electricity and magnetism technically are one fundamental forces. If you're talking about the fundamental force of the universe, there are actually 4, which go out like this: gravity, electromagnetism, strong nuclear force, and weak nuclear force. Yeah, so some people actually say that it's gravity, the nuclear force, electricity, and magnetism. Personally, I actually like the 4th one better, but most people use the gravity, strong and weak nuclear force, and electromagnetism. So I'm gonna go ahead with the one I just said. But however, this one doesn't seem to think so. So here you are. Electricity and magnetism. Now, magnetism itself is a weird thing because it doesn't really have an endpoint or a start point. It's always a big loop-de-loop because there's no definitive North Pole and South Pole. We just say that because it just makes our brains easier to understand. There's no one North Pole and South Pole, so. Every magnet themselves have their own North Pole and South Pole. Every atom themselves have one. And then we have electricity field lines where it starts from positive protons and ends at negative electrons. In gravity, it always just shrinks in. Gravity is what makes things try to compress themselves in singularities. And this is also one of the ways the universe could end. However, I really hope it doesn't, because if it does, gravity comes in and then bounces back out. That will be the best thing possible, because that means the universe is infinite and that God probably will just restart the universe over and over again. Yay! For the religious people who think God exists, that is, I wonder what would happen if the universe will never end but keeps expanding and expanding. Well, that's up to you to choose, I guess. Here are the basic circuit symbols that you really need to know. And my favorite are these because it feels like it's a secret symbol that anyone can really understand. You can literally understand any symbols by just looking at them and seeing what group they're in, to be honest. Also, like these ones, you're probably going to need to read the labels and memorize them. These, you probably don't even need to. You could just compare to each other. Except for this one, maybe you need to read the label. However, in my opinion, this one is the easiest. These 2 symbols are the easiest to understand. And that's pretty much all I have to say. And finally, elements of the periodic table. The periodic table, no one gets stable. Halogens and alkali react aggressively. Yeah, I love that song. That's the only way I seem to take out my arguments too. So, in conclusion, physics is about science, basically. Without physics, you probably don't have chemistry or biology either. You need physics to be able to fix some things in both. You also need maths. And if you're going to go through physics, you need to memorize symbols and equations. Sure, you could add a lot of fun inside of it, but you still need to memorize the fundamental parts. And that's it. I hope you guys enjoyed this episode, and I'll see you guys soon. Till next time, Shnan out. Peace. Dun 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 dun. Bye.